We're now just 3 days away from the solar eclipse. It's not just a fun event, but a rare chance for scientists to better understand how sun activity can have major impacts on Earth communications and infrastructure. Joining us now is Jamey Jacob, professor of mechanical and aerospace engineering at Oklahoma State University, who will be running experiments during the eclipse as part of the NASA nationwide eclipse balloon program. Jamey, welcome. Great to be speaking with you. To begin with, what are you doing here with this experiment?
Yeah, what we're primarily doing is launching balloons across the country, across the entire path of the eclipse, from the beginning to the end, to really take measurements of what's happening in the atmosphere, looking at the impact of the eclipse, that Earth, that shadow of the moon, as it moves over the surface of the Earth, and how it's impacting things such as the weather and the climate.
And what's the point of all this? Why are we needing to take these measurements and find out?
Well, it's really hard to be able to predict things such as the weather. We all know, how frustrated we get when we have a weather forecast that says it's going to rain and then it doesn't. And it really just boils down to the Earth is a really complex system. And it's hard to model. We can't make a model Earth and put it in a laboratory and test it. This is a way for us to use this unique phenomena as really as a target of opportunity. We liken it to, dropping a pebble in a pond, and we're seeing what that reaction in the atmosphere is. That's going to really give us better forecasts at the end of the day.
And so all of this has something to do with gravity waves. Tell me more about that.
Yeah, so going back to this pebble in the pond analogy, as this shadow moves over the Earth's surface, just like as you drop that pebble in the pond, you get gravity waves on the top of the pond moving out. The eclipse is doing the same thing. Waves are all around us in the atmosphere. Sometimes we can see these in striated bands of clouds. Most often we can't. But these waves are really responsible for moving a lot of energy around the Earth and have a big impact on our weather. And so it gives us an opportunity to improve our forecasts, since now we have this really unique phenomena that we can exactly model in our numerical weather prediction algorithms.
And what are you expecting your observations to be applied to? How will they be helpful in the future?
All this information is going to go back to really the atmospheric science community, groups like NOAA, NCAR, the National Weather Service, to really help refine their models. So that way we get a better set of predictions and algorithms. And at the end of the day, it's going to make your forecast more accurate. Not on Tuesday, where the eclipse is Monday. It's going to take months to be able to analyze this data and put this back into those weather models. But as part of this, we're going to be out observing the eclipse, and rain or shine, we're going to be taking these measurements, launching literally hundreds of balloons across the country and getting this data back into the scientific community.
Incredible. And are there any other final words you have before we finish up here?
Well, if you haven't had an opportunity to see an eclipse, it is really an awe-inspiring phenomena. And it's important to be in that path of totality, while seeing the eclipse outside is pretty amazing. It's a whole different show if you can be within that path. So, if your travel plans and the weather forecasts align, I really encourage people to go see it.
All right, Professor Jamey Jacob, thank you so much.
Thank you.